Hey guys, so today we're going to do section 3.2 and it's on differentiability. And remember, differentiability is just a scary word. It sounds scary. It means the derivative exists. So the first thing we're going to talk about is where a function could be not differentiable or where the derivative fails to exist. There's four main places where this can occur. And you're going to see it's actually more than four, but the first one is a corner. And a corner is exactly what you're imagining it is. My best example is in the function y equals absolute value of x. When we graph that function, just a basic graph. Remember, this one's hard elbows, so we have that V right here. It's that sharp turn, that really sharp corner where it's a straight edge on the left and it's a straight edge on the right. This point right here at x equals 0 is considered a corner. And the reason that one fails to exist is I want you to think about this in terms of our limits that we talked about. The slope of this left-hand side, this is just y equals negative x. So the slope here is negative 1. And the slope over here is just y equals x. So this has a slope of positive 1. So if this is a slope of positive 1 all the way down to 0, and this is a slope of negative 1 all the way down to 0, then at 0, it's both of those things. And if we can't come up with a value for the slope, then the slope does not exist. So corners are one place where the derivative will not work. The second type is called a cusp. And it sounds like a silly term, but a cusp is a function, and this is my favorite function, x to the 2/3 power. I think it looks like a first grader's version of a seagull. So if you actually graph this one on your calculator, it comes in curvy here to 0, and then it goes out curvy. So, right, doesn't that look like a seagull from first grade? That's how I drew birds in first grade. It's how I still draw birds, let's be honest. So right here, you've got a steep negative slope coming into 0, and on the opposite side you have a steep positive slope coming out of 0. So again, you have that same type of problem that we had here. If at least one of the two branches is curvy, then we call it a cusp instead of a corner. So right here at x equals 0, we have a cusp. The next one is called a vertical tangent, and the vertical tangent comes in, for example, in the function x to the 1/3, and I call this the swimmer graph. I think it looks like a swimmer. So the swimmer's arms. So in this particular function, again, you get this nice steep slope. In fact, it gets so steep that right here it goes vertical for a split second. So this point right here is called the vertical tangent. So again, at x equals 0 of this one, there's a vertical tangent. It goes vertical for just a moment. And then the last one is at a discontinuity. Now back from section 3 or chapter 2, we learned the 4 different types of discontinuities. So here I'm just going to list each one of those. The first type of discontinuity was a hole or removable. The second one was a vertical asymptote. The third one was the jump. And then I'm going to put it in here as well, but number 4 is the one we rarely ever see, but that's the oscillating. So technically there's 7 places that a derivative fails to exist: a corner, a cusp, a vertical tangent, and then these 4 different places. If it doesn't work in the original function, it's not going to work for the derivative either. So when we look at example 1, we've got this absolute value function, and they want to determine where f is not differentiable. So because this is an absolute value function, I can already make a guess that a corner is going to show up somewhere in this particular function. So I don't want us to plot points or use our calculator to figure this out. I want us to use our basic math skills of how do we move a graph. So if we think about this function y equals absolute value of x, this -2 here, what does that do to our function? Well, that moves it right 2. And then this +3 out here, what does that do to our original function? Well, that's going to move it up 3. So my new graph, I can even just sketch it. Instead of my V point being at 0, 0 like it was up here, now it's going to be over 2, up 3. So if I did over 2, up 3, there's my new V point, and then it's just going to go up 1 over 1, up 1 over 1. That's my new point, or my new graph. So where is this function not differentiable? Well, the corner is still the corner. So f is not differentiable. No, f is not differentiable at the point 2, 3. And if you even want to be more specific, there's a corner there. Now, you're going to need your calculator for the next part. That will be on the next video.